Do you know how to make this ridiculously awesome colorful LED cube? This bad boy packs a whopping 216 LEDs and runs on just 5 volts. Wait, it gets even crazier. All these 216 LEDs are controlled with one single data line. Yup, you heard that right. One data line. So, if you are wondering how the heck did I pull that off, stick around.
Step 1. Creating the schematic. First things first, we need to create the schematic for the project. Here, I have designed the schematic using WS2812C LEDs. I have added 36 LEDs, connected all of them in parallel to 5 volts and ground, and included a capacitor which smooths power fluctuations, reduce high frequency noise, ensuring stable voltage for WS2812C LEDs operation. I have also added a microcontroller, especially the ESP8266. People also call it as Node MCU. This setup is simple. The D4 of the Node MCU connects to D in of the first LED. The D out of the first LED connects to the D in of the second LED. And this pattern continues all the way up to the last LED. I've also added these conductive mounting holes or points which will aid us in joining these PCBs later. Finally, I have included a few details for project traceability, which is a must. Step 2. Designing the PCB. Once the schematic was ready, I quickly converted into PCB layout. I placed all components symmetrically and completed the routing. The distance between each adjacent LED is 10 mm and the distance between the LED and any edge is 5 mm. With this arrangement, I was able to place all 36 LEDs in 60 by 60 PCB. To make assembly easier, I've added constellated holes which will allow me to join the PCBs seamlessly. Then I poured a ground plane on both top and bottom layers, added wires and stitched the both layers together using these wires. You might ask, why the heck these wires are so big? These oversized wires help dissipate heat by allowing the better air circulation, especially since the final cube will be fully enclosed. Step 3. Sharing the design with Altium 365 or storing the design on Altium 365. Once the routing was completed, I uploaded the project to Altium 365. This cloud-based application lets me share the design with others for review and get feedback. And it will also allow me to share the files with you. You can access this project files through the same Altium 365 link of this project attached below in the description. To make it easier for you, I've skipped adding my logo or any promotional content on the PCB. So you can directly print or fabricate them and use in your projects or make a project out of it. What is Altium 365? It's a cloud-based platform that connects everyone involved in the electronic product development. And the best part of the Altium 365 is it's not only limited to Altium Designer users. You can connect Altium 365 with other ECAD tools like Eagle, KiCad or even OrCAD. Plus, it's completely free. You don't have to pay a single penny for this. If you are new to PCB design, Altium Student Lab offers an excellent free course called Learn Printed Circuit Board Design. This course covers schematic creation, PCB layout, routing and even manufacturing. I've made a separate video to guide you through the sign-up process and how to get your Altium Designer license and get started with Altium 365. If you're interested, you can check out that later. I'll leave the link of the same video in the description of this video. Step 4. Generating manufacturing files. Next, I generated the Gerber files or manufacturing files by navigating to File, Fabrication Outputs, Gerber X2 files. I always choose the Gerber X2 format instead of standard Gerber files. If you choose Gerber files, you have to generate drill files separately. I don't want that. In addition to Gerber X2 files, I also generate the pick and place file and bill of materials for assembly. Step 5. Ordering the PCBs on JLCPCB. Now it's time to order the PCBs. I use the JLCPCB for this. Here's how. Upload the Gerber files to their website. Double check the design using their Gerber viewer. Set the following parameters: PCB quantity 10 pieces, PCB color black, silk screen white, and surface finish ENIC because of the constellated holes. Select yes for the constellated holes and specify that they are on all 4 edges. Opt for PCB assembly and choose only top side and choose the custom quantity, which is 8 pieces. I would like to keep the rest of the 2 for review purposes. Pro tip: the WS2812C LEDs need a 48-hour baking process to remove moisture. Skipping this step could lead to water droplet formation during assembly, damaging the LEDs. So let's opt for baking process as well. Click next, select which side of the PCB to populate, upload the BOM and CPL files and proceed. One thing I really love about JLCPCB is their interactive assembly preview. You can see exactly how your board will look before assembly, eliminating potential production issues caused by human errors. This preview is generated based on your Gerber, BOM and CPL files. So there is no room for any human errors if you did not mess up with this process. Honestly, whoever developed this feature at JLCPCB deserves a rise. It's a game changer. Step 6. Finalizing the order. Add the PCB to your cart. Proceed to checkout and enter your address. Here you should be more cautious. If you are not from China, there will be a customs process involved. So whatever address and your name you will be entering, please make sure that you have a supporting documents for that. Otherwise, you will end up with the back and forth with the custom people, and even sometimes your parcel will not clear the customs. Select the shipping method and complete the payment. Alright, that's all for now. Let's take a break and wait for the PCBs to be manufactured, the components to be sourced, and everything to be assembled and shipped to us. Once that's all set, I'll be back with the next episode where we will unbox the PCBs, assemble the LED cube, and get into the fun part, programming it to light up and showcase its full potential. Trust me, you won't want to miss that. So make sure you stay tuned to Electronics Innovation for the next step in this awesome project. See you in the next episode. Bye bye.